Here's the secret. When I differentiate, I almost never use the quotient rule. Let me show you why. So I want to find the derivative of this function. I have 6x plus 5 in the numerator, and I have x cubed minus 2x plus 1 in the denominator. But I'm not a huge fan of the quotient rule, so let's rewrite this function as a product. So we rewrite f of x as 6x plus 5 times x cubed minus 2x plus 1. It's in the denominator, so I use the exponent -1. So now, instead of being a quotient, this thing is a product. Now I don't really have to worry about which order I take the derivative in, as long as I take the derivative of both, use the product rule, that sort of thing. Product rule is way easier to remember. So, f prime of x, in this case, well, let's start with taking the derivative of the first function. That's 6 times the second function, x cubed minus 2x plus 1 to the -1. Plus, okay, and then I have the first function, 6x plus 5, times, well, the derivative of the second function now is a little bit complicated because I have to use the chain rule. Because I have this guy and then the power up here, so I use the power rule, and the power rule says that I have -1 times x cubed minus 2x plus 1 all raised to the power -2. So I subtract 1 from the exponent, and I ran out of space, so I'll put it down here. But then I have to multiply. This isn't just the derivative of this function. I have to multiply by the derivative of the inside function, which in this case is 3x squared minus 2. So I'm using the chain rule there. Pretend like this is one big blob. Use the power rule, -1 to the -2 power, and then take the derivative of the inside blob. All right, so if I rewrite this a little bit, so this is the derivative, and I could really just stop there if I wanted, but let's just make sure that we didn't really fool ourselves here. So I can rewrite this a little. This -1 can become a subtraction in between the two terms. So this is 6 times x cubed minus 2x plus 1 to the -1 power minus 6x plus 5 times 3x squared minus 2, and this guy here is all to the -2 power, so I could put him in the denominator. X cubed minus 2x plus 1 squared in the denominator. All right, so now I probably want to combine these things together. This is starting to look a little bit like the quotient rule. But I have to make this thing into some kind of denominator of this with the second power. Well, luckily, these terms are the same, and this is to the first power in the denominator. So what I really have here is I have x cubed minus 2x plus 1 to the -1 is the same thing as 1 over x cubed minus 2x plus 1, which is really the same thing as x cubed minus 2x plus 1 all over x cubed minus 2x plus 1 squared, right? Because I could just cancel one of these terms, and then I'd be left with this. So, using this fact, I can rewrite this part of the term, and now I have that the derivative is equal to 6 times x cubed minus 2x plus 1 all over x cubed minus 2x plus 1 squared, minus that other term, which was 6x plus 5 times 3x squared minus 2 all over x cubed minus 2x plus 1 squared. Well, now the denominator is the same, so I could combine 6 times x cubed minus 2x plus 1 minus 6x plus 5 times 3x squared minus 2 all over x cubed minus 2x plus 1 squared. And you should check that if you had used the quotient rule on this problem, this is exactly the form that you would get. So instead of using the quotient rule, I used the product rule and made it a little easier on myself. This is my particular way of doing these problems, and a lot of people agree with me that they think this is easier. But there are a lot of people who still really love the quotient rule, and they like using the quotient rule for problems. If that's you, keep going. Use the quotient rule. And if it's not you, feel free to use the product rule as long as you use the chain rule appropriately. Good luck!